So go through here if you are having more questions than the ones we answered in class today on this review. Hopefully your browser will allow you to fast forward to the ones you need to see, but I'm going to go through each of these. So on number 1, exponent rules, I need to deal with each piece separately. So I've got my coefficient piece, my x piece, and my y piece. On the coefficient piece, 4 over 8 reduces to 1 over 2. So I put my 2 on the bottom. I know that I may or may not need the 1 on the top. X's, if I look at my x terms, when you divide, and that's what fractions are, is division, you subtract the exponents. Remember that the leftovers should always go where the bigger exponent was. So 5 is bigger than 4, so my leftovers should go in the bottom. 5 take away 4 is 1, so it's x to the first in the bottom. Then my y's, y to the 7th over y to the 3rd. Again, subtract the exponent. 7 minus 3 is 4. The bigger one here was in the top, so that goes in the top. Number 2. Everything in here needs to get this -3 exponent. So make sure the coefficient gets it. Make sure the x term gets it. Make sure the y term gets it. So -3 raised to the -3. Then my x term, x to the, this is power of a power. So you multiply those exponents. So -27. Now, -2 times -3 is +6. So y to the 6th is going to go on the top because this is a positive exponent, no like terms to combine with. These are both negative exponents, which means they need to get booted to the bottom. So that -3 raised to the -3rd, when I move it to the bottom, is raised to the +3rd. This x to the -27 becomes x to the +27 when I put it in the bottom. Now this still needs simplified because I know what -3 raised to the 3rd is. It's -27. So I put that in, I put in my x to the 27th, and there is my final answer. On number 3, there's lots of different ways to do it, but I would suggest, since the numbers are relatively small, just going ahead and multiplying first and then simplifying. So numerator times numerator here, 5x, there is no x over here, so it's just going to be x to the 5th again. The y's times each other. When I multiply terms, I add the exponent. So -3 plus 3 is 0. In the denominator, the 15 has nothing to combine with, so it stays. X squared times x to the -3rd. Again, this is multiplication, so you add the exponents. Notice the difference between this and what I had here. Here, the exponent was on the outside. That's why I multiplied. Here, I just have two different terms with exponents, so I add the exponents. So now I need to simplify. The 5 over the 15, they're both divisible by 5, leaves me a 3 in the denominator. My x's, when I divide, I subtract the exponents. 5 minus -1 is 6. So it's x to the 6th. The bigger one was in the numerator, so that's where my x to the 6th goes. Y to the 0, anything to the 0 power is 1, so that just becomes a 1 and filters in. So that is your answer. Number 4, I said this in class, I'll say it again, please do not FOIL this. Please, 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 please do not FOIL this. This is subtraction between, not multiplication. So all you need to do here is distribute the negative and then combine your like terms. So those are like terms. Please write your answers in standard form. That's part of the directions, but it's something that you should always know to do anyway. So x to the 4th is your biggest exponent, then your x cubes, and then your x's. All right, this one is multiplication because nothing's written between. So to multiply a binomial times a trinomial, you're either double distributing or double distributing in a more organized fashion, which is using the box method. Again, if you like to double distribute and you generally get them correct, that is perfectly fine. I will not force the box upon you, but if you make a lot of mistakes, you might want to consider the box. So now, x times 2x squared gives me 2x cubed. 12 times 2x squared gives me 24x squared. X times negative 3x is negative 3x squared. 12 times negative 3x is negative 36x. X times 5 is 5x. 12 times 5 is 60. So now, combine your like terms. These are like terms, and these are like terms. So it's 2x cubed, then 24 minus 3 is 21, so 21x squared. Negative 36 and a positive 5 gives me a negative 31x, and then my 60 on the end. Number 6, same idea here, just in a different format. When you have something cubed, that means multiply it by itself 3 times. So, first step, you need to FOIL 2 of them together. So, when I FOIL these first 2, I get firsts, x times x is x squared, outsides, negative 3x, insides, negative 3x, and lasts, positive 9. So that gives me x squared minus 6x plus 9. I now don't write that in your final answer. We're not done. The only thing we've done is these 2. I still need to multiply by this other x minus 3. So I'm going to box that in order to multiply. So x squared times x is x cubed. X times negative 6x is negative 6x squared. X times 9 is 9x. Negative 3 times x squared is negative 3x squared. Negative 3 times negative 6x is positive 18x, and negative 3 times 9 is negative 27. So now combine the like terms. So x cubed, these 2 are like, that gives me negative 9x squared. These 2 are alike, which gives me 27x, and then minus 27 on the end. All right. Number 7, factoring. So, factoring order of operations. Again, the first thing that we do when we do factoring is the GCF. So, I look here. On number 7, I do have a GCF. It's 2, so take the 2 out in front. That gives me x cubed plus 27. After GCF are special products. So, your special products are difference of squares, PSTs, and sum and difference of cubes. So this can't be a difference of squares because they don't have square roots and it's not a minus. It can't be a PST because it only has 2 terms. It is a sum of cubes because x cubed and 27 both have perfect cube roots. So that means this is going to be SOAP. So I fill in my signs. Same as the original, opposite of the original, always positive. The binomial, you look at this, don't look back at the original, look at the one that you've already taken the GCF out of. The cube root of x cubed is x. The cube root of 27 is 3. Now, to get the trinomial, you square the front to get the front. So x squared, middle multiply, x times 3 is 3x. Square the back to get the back. 3 squared is 9. And so I'm not actually going to rewrite it. This is the answer right here, even though I'm not putting it on the answer line. All right, next one. Again, always, always, always check for your GCFs first. This one has a GCF of 3. So that gives me x to the 4th plus 2x squared minus 15. Now, I took the GCF out. Next, I look for special products. This is not a difference of squares because it has 3 terms. It's not a PST because I don't have a perfect square root here. I know it's not sum or difference of cubes because it's 3 terms. So that means it's not special products, which means that it's chart factoring. This one is factors that add. What multiplies to negative 15 and adds to positive 2. So that would be positive 5 and negative 3 that add to 2 and multiply to negative 15. So because this is factors that add, that means those answers go directly into the parentheses. But please be careful. This is a higher order polynomial. Pay attention to your exponents. Don't just put an x here. The original was x to the 4th. So this one should be x squared. And I need my plus sign there. Then I look to make sure they don't factor further. This can't be a sum of cubes, so it doesn't factor further. This is not a difference of squares or a difference of cubes, so nothing else I can do there. So that is my final answer. Number 9, solve by factoring. So to solve by factoring, I look, there is no GCF, then I look for special products. This is a difference of squares. So x plus 7 times x minus 7. Set each of those equal to 0, which gives me both positive and negative 7 as my answers. Number 10, this isn't even in the right form for factoring yet. In order to solve by factoring, you have to have it equal to 0. So the first thing that I need to do here is subtract the 12x. So after I take out the 12x, I next take out my GCF. They all had an x in common, so that is how I got this next step, is I factored out the x. Now I look at what's left. Just because you took out a GCF doesn't mean you're done. Now I look at this. It can't be a special product because I don't have perfect square roots and it's a trinomial. So that means this is chart factoring. It's not factors that add because there's a number in front, which means I'm looking for what multiplies to negative 24 and adds to negative 5. So that answer would be negative 8 and positive 3. So we split the middle term. That's why it's called split the middle. We split the middle term of negative 5x into these two terms. And now we will factor what remains by grouping. So group these two together. The GCF of this group right here is 2x. If I factor the 2x out, I would have x minus 4 remaining when I distribute it back out. If that's x minus 4, then so is this one. Work backward. What do you multiply x by to get 3x? It'd be positive 3. Do not forget that you had that lovely x of the GCF out in front. To write my final answer, I've got the x from out in front. Then this is one of my parentheses, what's in the fronts, so 2x plus 3, and then my x minus 4. Some of you have been putting like x minus 4 squared. These have to be the same because when you put it over here, there's only one of them. Oops, I almost forgot to solve this one. Crazy me. It's probably because I ran out of space. So now I need to solve it, so set each of them equal to 0. So x equals 0. 2x plus 3 equals 0, which means subtract the 3 and then divide by 2. So x equals negative 3 halves. And then if x minus 4 equals 0, add the 4, x equals 4. Number 11, there is no GCF and it has 4 terms, which means the only way it factors is by grouping. So first group has a GCF of x squared, which leaves you with x plus 1. This has to be x plus 1 also. Work backward. X times 9 is what gives you the 9x. So the factorization is x squared plus 9 times x plus 1. So set each of those equal to 0. If x squared plus 9 equals 0, subtract the 9. X squared equals negative 9. Here, x equals negative 1. This one, you still need to take the square root on both sides. Square root, square root. So x equals, the square root of negative 9 is plus and minus 3i. Don't forget the I, because it was a negative under the square root. And then this one, of course, stays the same. X equals negative 1. End behavior, dance moves. So if you know your dance moves, you know that this has a positive leading coefficient and an odd degree. So that means that its ends should go up on the right and down on the left. If you graphed it, it should have some kind of shape like this. So again, as x approaches infinity means as I go to the right. As x approaches negative infinity means as I go to the left. So what's happening? On the right, it's going up. On the left, it's going down, which is what I put here. This one has a negative leading coefficient and an even degree. So negative evens, dance moves, both hands are going down. So same thing happens if you look at the graph, and I'm not sure exactly what this graph looks like, but probably something similar to that maybe. So both ends are going down, which means both approach negative infinity. Algebraically determine if the function is even, odd, or neither. Show work. You have to plug in negative x for all of your x's. So every time I see an x, I put negative x in its place. Please remember to put parentheses around it. That's important. So now simplify the expression. Negative x raised to the third power is going to be a negative x cubed. Negative x raised to the second power is going to be a positive x squared. But then I have to multiply that result times the negative 5. So negative 5x squared. Plus a negative becomes a negative, and then my minus 1. So I look. In your even odd notes, we have that chart that shows you, are they all exactly the same? If they are, then that means it's even. These are not all exactly the same because these aren't the same. Those are opposite. In order to be odd, they all have to be opposite. So none of them are the same. Well, these ones aren't the same, but these ones are. The x squared terms are the exact same. So anytime you're switching back and forth between being the same and being opposite, that means that it's neither even nor odd. So it has to be all of them the same to be even, none of them the same to be odd. If you have a combination, it's neither. Number 15, looking at the graph. Even would be symmetric about the y-axis. This is not, because if I folded it here on the y-axis, this little hill would end up over here, which it's not. So it's not even. In order to be odd, it has to be symmetric about the origin, which means for every point I see, I should be able to draw a line through the origin the same length to get to the other side. So let's say I'm taking this point. If I take that point and connect it to the origin, and then go the same distance in the other direction, I should end up on an exact other point, which I do. Now, just because it works once doesn't mean it works all the time. How about this point? Connect it to the origin, right there, then go the same distance the other way. Oh, here I am. Let's try it again. Here, connect, same distance, other way. Seems to be working. Here's the true test. Does every point x, y have a negative x, negative y to go with it? So if I look at this point, and I can't read it on this screen, but on my paper I can, and it looks like the coordinates of that hill are approximately 2, 1. So if 2, 1 is on there, then -2, -1 should be on there. And if I look, -2, -1, it is on there. So this is symmetric about the origin, which means it is odd. Remember that whether a function is even or odd is not the same as whether its degree is even or odd. They're two different things. All right, page 2, divide using long division. So set up what you're dividing by over here. This goes on the inside. Please remember that if you are missing a degree of the function that you have to enter a 0 for it. So many people still missing that. So first question, what do I multiply blank by to get blank? And in this case, what do I multiply x by to get, in this case, x cubed? So what do I multiply x by to get x cubed? I multiply it by x squared. So now multiply is my next step after I line it up over like term. So I lined it on top of its like term. Next, I'm going to multiply. So x squared times x is x cubed. X squared times -1 is -x squared. Now I need to change the signs. So this becomes a negative. This becomes a positive. Now add the columns. Add these, they drop out. Add these, it gives you -x squared. Next, bring down the next term. So bring down my -8x and repeat the exact same steps. Now I'll put it in a different color. What do I multiply x by now to get -x squared? I multiply by -x. So we lined it up on top of its like term. Now I'm going to multiply. -x times x is -x squared. -x times -1 is positive x. Change the signs. Plus, minus, and for some reason I forgot the x there. It really was there. Drop these out because they cancel. -8x plus -x is -9x. Bring down the next term. Repeat again. What do I multiply x by to get -9x? -9. So multiply -9 times x is -9x. -9 times -1 is +9. So now change the signs. Add the column that gives me -4. If you go to repeat, you're out of room, which indicates this is your remainder. When you write your answer, you've got your x squared minus x minus 9. Your remainder, remember, you write plus a fraction. This goes on top, and the bottom is whatever you were dividing by. So in this case, x minus 1. And so that is your final answer. Synthetic division. Do not forget to change the sign here. This is a +3, which means the box should have -3. So now I need my coefficients from what I'm dividing. So 1x cubed, after x cubes should come x squareds, and there isn't one, so you need a 0. After x squareds come plain x's, so -10. After the plain x's come constants, so negative 24. So bring down my first term, multiply box times bottom to get negative 3, then add the column. Box times the bottom is 9. Now add the column, negative 1. Box times the bottom is 3, which gives me negative 21. Do not forget the part that is underlined. This is your work. The answer is when you write it as a polynomial. X squared, because it's 1x squared, minus 3x, minus 1, and the last one is your remainder, plus negative 21 over what I was dividing by, which was x plus 3. All right, find all zeros of the polynomial function. So first thing I do is I list my possibles. So in this case, my factors of my constant are my p, factors of the leading coefficient are my q. So factors of negative 1 are just positive and negative 1. Factors of q, well, q is 1, 2. So that means my only possibles are positive and negative 1. After my possibles, I graph to see which of my possibles might be actuals. When I draw the graph here, and again, you don't need to change the window because you don't really care about anything except where it crosses the axis. So it looks like, and of course I drew it wrong because I'm very silly. Let's pretend that I drew this right. It actually goes through here, not there. So here, this one's in between. That's not one that we want. This one's in between, so we don't want that one either. These are the two that are on integer values. So that means positive and negative 1 are my options. What I do with those options is put them in the synthetic division. It doesn't matter which one you take first, whichever one you want. So let's say I start with the 1. Set up synthetic division. Here are my coefficients. 1x to the 4th, negative 4x cubed, 0x squared, 4x, negative 1. Box times bottom is 1. Add the column to get negative 3. Box times bottom is negative 3. Add the column to get negative 3 again. Box times bottom is negative 3. Add the column to get 1. Box times bottom is 1. Add the column to get 0. Remember, if you don't get remainder 0, you've got a mistake in there somewhere. Did you forget 0 as a placeholder? Did you accidentally put the wrong number in the box? Did you graph it incorrectly? Did you just multiply and add incorrectly? But if you don't get 0 here, you did something wrong. So now, my original was quartic, which means quartic means double synthetic. So that means I have to do it again with the other one. I haven't used the negative 1 yet. You can't use the same one twice. That won't get you anywhere. So now do the synthetic division again. Bring it down. Negative 1 times 1 is negative 1. Gives you negative 4, positive 1, negative 1, and 0. So now don't stop. You're not done yet. You have to solve this quadratic because that means x squared minus 4x plus 1 equals 0. You have to solve. So I completed the square on this because I always complete the square when my middle term is even because it's faster than the quadratic formula. So I moved this one to the other side and now I'm going to complete the square. So my square value is b divided by 2 squared. So that gives me positive 4 in my box. 1 times 4 is 4 on the other side. So this guy, I need to factor it. So x minus 2 squared. On this side, 3. So now square root both sides gives you x minus 2 on the left. On the right gives you plus or minus radical 3. So now just add the 2, and you've got x equals 2 plus or minus radical 3. That's why these didn't come out evenly and they weren't in my list, because they're not rational zeros, they're irrational. They have a square root. Now, this is just 2 solutions. This is quartic. So how many solutions should it have is the same as the degree. There should be 4. The other 2 solutions are these ones. Make sure you list them on your answer. So now I've got 4 answers listed. I've got a degree of 4, so I'm good to go. Next, 19, same exact thing, different equation. List my possibles. Oops, I forgot to write out the rest of the steps here. Guess I might as well do that. So step 3, remember, was synthetic division. And then step 4 is to solve the quadratic. Okay, so step 1, possibles. So I look up here, my P and my Q. P is 7, so the factors of 7 are positive and negative 1, positive and negative 7. Q, positive and negative 1. So that means my possibles are positive and negative 1 and positive and negative 7. So when I look at my graph, I better see some of those as integer zeros, at least one of them. Since this is cubic, I need to have at least one 0 that shows up. When I graph this one, you almost can't see very much of it at all in the standard window, but you can see a little bit of the curve, and it looks like this. So that value looks like x equals 1, and it's the only x-intercept you can see. So that's what I put in when I go to step 3. Again, step 3 is to do the synthetic division. So put positive 1 in my box, because that's the value that I see is x equals 1. My coefficients, it's 1x cubed, 2x squared, 4x, and negative 7. I didn't need any zeros here because I wasn't missing any of my terms. Bring down the 1. 1 times 1 is 1. 2 plus 1 is 3. 1 times 3 is 3. 4 plus 3 is 7. 1 times 7 is 7. And I do get 0, which is good, because that means that is indeed a 0. So now, I don't need to do double synthetic here. My original's cubic, not quartic. So that means this is my quadratic, x squared plus 3x plus 7, and then I set it equal to 0 to solve. Now, this one is not factorable either, but I'm not going to complete the square because I would have to do so with fractions. So usually if it's going to be a fraction, I use the quadratic formula. So I'm going to do opposite of b plus or minus square root b squared minus 4 times a, which is 1, times c, which is 7, all divided by 2 times a. So negative 3 plus or minus square root 9 minus 28. 9 minus 28 is negative 19. So I need to simplify there. I've got a negative under the radical, which means that's i's in my answer. Plus or minus I, radical 19, over 2. This is only 2 answers. I should have 3. Don't forget the one that was synthetic division. So x equals 1. Almost there. Write a polynomial function of least degree that has real coefficients, the given zeros, and a leading coefficient of 1. So if negative 3 is a 0, that means x plus 3 is a factor, because minus negatives become pluses. If 1 is a 0, that means x minus 1 is a factor. If 5 is a 0, that means x minus 5 is a factor. So now this turns into the same exact thing that I did way back on page 1 when I cubed something. I need to FOIL these first 2 together first. So x times x is x squared. X times negative 1 is negative x. 3 times x is 3x. And 3 times 1 is 3. So combine these like terms in the middle. I've got x squared plus 2x plus 3. X minus 5. So x times x squared is x cubed. Negative 5 times x squared is negative 5x. X times 2x is 2x squared. Negative 5 times 2x is negative 10x. X times 3 is 3x. Negative 5 times 3 is negative 15. And then combine my like terms. Here's like terms, and here's like terms. So I've got x cubed minus 3x squared and minus 13x oops, I made this a plus. This is supposed to be a minus, and I didn't catch it until now. Good thing I caught it at all. This is a negative 3x, so that's how I got negative 13. And then my minus 15. Sorry about that. Even I make mistakes occasionally. At least I caught it. All right, 21, same thing. If 4i is a 0, x minus 4i is a factor. If negative 1 is a 0, then x plus 1 is a factor. But this one has an imaginary. Imaginaries always come in pairs, which means, even though it's not stated, that x plus 4i must be a factor also. You will never ever see a single imaginary that doesn't come with its conjugate. So this is the conjugate of this. Now, FOIL these two together first. X squared, the outsides and the insides cancel. They're opposites. So there's no O and I here. It's just now the last. It's minus 16i squared. Minus 16i squared, negative 16 times negative 1 is positive 16. So you've got x squared plus 16 times x plus 1. Now you can FOIL that. So x squared times x is x cubed. X squared times 1 is x squared. 16x and 16. There are no like terms here to combine, so that is my final answer. All right, last one, and this one's in the calculator. So if you have questions on this and you don't have your graphing calculator, you probably need to go get it, because you can only do the first two problems without it. So total number of roots you should know from looking at the degree. So the degree here is 3. The number of turning points should be, at most, it could be less, but it should be degree minus 1. So 2 should be the most that we should see. X-intercepts, local maxes, local mins, we need the calculator for. So punch this function into your graphing calculator and graph it. In your standard window should be fine. If you want to make your window smaller to match this, you can. So I'm just going to do a rough sketch down here. That's kind of what it looks like. So when I'm finding the x-intercepts, there are 3 of them. Here's one, here's one, and here's one. So x-intercepts, press second, trace, and then choice 2, because x-intercepts are zeros. So on this leftmost x-intercept, when it says left bound, that's here. This is the left bound. So move your blinky over here somewhere and press enter. Then your right bound is right here. So move your blinky over here and press enter. Then it'll say guess, press enter a third time. It should give you this x-intercept, which is negative 1.09. And of course, the y-coordinate is 0 since it's an x-intercept. This x-intercept in the middle, I have to do that next. So same thing, second trace choice 2. But this time, left bound. Again, left bound just means to the left of the 0. the points to the left of the 0 are here, over here. So this is left bound, and this is right bound on this 0. So do your left bound, right bound, press enter a third time to guess. That one is, I think that says 1.57, if I can read my own writing. 1.570. One more of these right here. Left bound, again, means to the left of the 0, so that's here. This is right bound. When you tell it to guess, it should tell you 3.510. So now you can plot all those points if you want, or you can continue with the mins and maxes and then plot them. I'm just going to go ahead and plot these now. So negative 1.090 is right here. Then 1.570 is right there. And then 3.510 is right here. So there you go. Now local max. A local max is a hill. These are my hills. So in the calculator, you do second trace, and I actually can't remember what number choice it is. I'll have to look at it, but it's second trace, you choose maximum, which is choice 4. So second trace choice 4 to find the max. You do the same thing with the left bound, right bound. I only see one hill. It's right here. There's my maximum. So when I do left bound, left of the maximum would be somewhere over here. Right bound for the maximum is somewhere over here. Tell it to guess. You should get the maximum to be at 0.3. Remember, we're rounding to the nearest hundredth. And also remember, if you get the E thing where it says, you know, like 1 point something, 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 E, negative 14. Remember, I said this means 0. So if you get that, that's what it means. So 0.3 is my local maximum. That's my hill, so I'm going to plot that. 0.3. Local minimum. A local minimum is a valley. So I'm looking, I only see one valley right here. That's my minimum. So this is left of the minimum, this is right of the minimum. So you go second trace, choice 3 in this case gives you minimum. Do the left bound, right bound. It should give you for the valley 2.67, negative 1.74. All right, so plot that. 2.67, negative 1.74 should be right about there. Okay, so now when I connect it, again, yes, I'm picky about this because the point is the whole purpose of this section was to produce accurate graphs. We already know how to do sketches. We already know how to do all of these second trace features. Those are all review. The only thing that's new is making the graph very accurate. So when you look and you know this is a hill right here, make it a smooth hill going through these. When you know that this is a valley, connect it with a smooth valley. Then end behavior. If you look on your graphing calculator, there are no more hills, valleys, or intercepts after that, which means that this continues in this direction. Same thing over here, it continues in this direction. Your end behavior, you can look at the graph if you want. As x approaches infinity, so on the right side, it's going up, so positive infinity. As I go to the left toward negative infinity on the x, it's going down. Again, you could get that with dance moves also because this is positive with an odd degree. All right, that finishes up all the problems. Please remember to study by doing. Just listening to me, for most of you, is not nearly enough. Do the problems yourself and study. I will see you tomorrow.